Okay, firstly, I gave you extra pages of the graphs that I actually wanted us to practice this week, but I have, in the meantime, decided that I'm not going to do that. I want us to finish up with graphs today. The reason for that is it only counts between 9 and 20 marks in a question paper. Rarely does it count 20, so it doesn't count that much. Okay, and I think we've done quite a lot of it, and the thing that you need to understand is it's work that you must learn. You must learn the mother graphs, you must learn the methods, you must learn what A is and how to calculate it and what it does, and B and P and Q. So we can't be wasting time going over this over and over and over and over again when all it takes is you going to learn the work. And that's all you need to do. Okay, so I'm going to finish up with it today so that we can start with the sine and the cosine and the area rule tomorrow. Okay, let's just quickly look through these pages. So the 3 pages that I handed out to you now is a summary of all the trigonometry that we've done up to date. Can you believe that? From last term up until now. Okay, it's actually 6 pages, but I think it is summed up very well. So you can just look through it. Please keep it, just, if you put it in a file, you didn't use it, ne? You have to study it. Go and remake your own summary of this work. Use color, what. This just make sure that you have everything included. So we learned about the reduction formula. So which quadrant is which one? This one here at the top, reduction formula. They're giving you examples there about how to take it to the smallest angle, to the reference angle. You know how to do that. There you see the special angles. All you need to know about the special angles is which ones are special, and then you can just use your calculator to give the answers. At the bottom we see there is Pythagoras problems. Isolate the ratio. Get the function alone on one side, né? And then you have the number on the other side. Determine the quadrant. Draw a sketch and use Pythagoras. And you can even add there plus minus so that you remember I must choose the positive or the negative. And then answer the question. This we know we use the diagram and Pythagoras when we're not allowed to use a calculator. Né? You remember that? Then that's going to be what we're going to look at. Right, yeah, you can just look through that if you want. Please page for me. On the next page we have the negative angles. There's a method 1 and a method 2. We use method 1. Okay, so you don't even have to look at method 2. It just says that the sin of a negative is the negative sin. The cos of a negative is a positive cos. The tan of a negative is the negative tan, and then you're done with it and you go on. Eh? Okay, they give you some examples there. There's the problem solving cos 25 equal to P, expressed in terms of P. They give you the example there. You know that one. We've done it so many times. There's the co-functions. You can look through full cos diagram. You know that. That's just with the 90 degrees. Proving identities. Separate the left-hand side and the right-hand side. Remember, when you do this, you don't carry the equal to sign and the other side with you. You simplify the most complex side. They say they start on the more complex side. If you get to a point where it can't be factorized anymore, then by all means you can go to the right hand side, but you stop with the left hand side. You don't use the equal to sign now in the middle. You go on with the right hand side, but underneath the left hand side, not and on the right hand side. Do you understand what I'm saying? No. So it mustn't follow each other until you've simplified both as far as possible, and it rarely happens that you're going to simplify on both sides in any case. But if it does happen, then you know. Okay. That was it. Then we get the trig equations. Right, so once again, isolate the trig ratios. Choose the quadrants, general solutions. Now there is once again 2 types of questions that we can have here, and that is when they say find a general solution. That means you can use a calculator. If they say without using a calculator, you will once again have to refer to a diagram. Okay. and calculate the third side so that you can give any answer. There it is. They also show you the factorization, the different factorization that you can have there. Different methods of doing it. You can have a look there. Maybe something that we haven't used. Whatever, you can just look through it there. Okay, there's also factorizing. And then on the next page starts the graphs. You will see starting off with the three main basic mother graphs. Sin, cos and tan. If you don't know them, you won't be able to do the graphs. Okay. You need to know what they're supposed to look like, otherwise you can't determine how the specific graph is changed or has changed. You can go and look through it, everything there, examples and so on. And the horizontal shift is there on the next page. And also there is the sum, that example there in the middle. The solution is on the right hand side. That's the one that only some of you were in class here. So I just want to talk to it about it again. You're giving a step back. You're doing the sum backwards. Where sin 2x is in its simplest form, we want to take it back to a co-function. Okay. So therefore, I changed the sin to cos, but then I need to put in the negative. What we normally did is, it was given with a 90 degree. Did I say negative now? Excuse. It's given with a 90 degree, and then you take the 90 away and you change the sin to cos or other way around. Nee? That's what we used to. Now there is no 90 degree, but I want the sin to change to a cos and other way around. So I change it, but then I have to put in the 90 degrees. Okay. And the reason why we always use 90 minus is because that keeps us in the first quadrant. So there's no sign change or anything other happening. Once you have your functions the same, you can throw them away and you simplify it. You will see there obviously some of the methods, some of the steps will differ from what I showed you. Someone else setting this up. But the basics remain the same. Okay, we're also going to do another one of this now in class to get it over and done with. But that is, it also goes on the next page. You can just look there. Please work through it. Please do. Those are the restrictions there. We did that as well. It's very important, guys. Don't just file it. Okay. Now I'm going to give you some more question papers. We are just going to work through one of them right now, one of the questions. And then do a similar sum to that other one. want you to look at the first page quickly. Question 5. This is, for example, November 2018 question. I just want to show you how it's the same over and over again. I know I've done it, but I want you to understand this so you know what to focus on. There's that question with the diagram. Sometimes they give you the diagram, sometimes you have to go and draw it yourself. You must know how to do both. You're gonna close the diagram to draw a Pythagorean triangle. Yes, it will happen that they might throw something in there that's a little bit different. So for example, here you have the y value and you have this value up into -2 for the x value. So you don't know, there might be a little bit more to it, just a bit more of a struggle, but they tell you that OT is 17 units. So therefore you have the radius, you have the y value, you can calculate the x value. But then they are referring to a value there that you're going to have to calculate and the x value there. It's in ratio. It's in a ratio. If that r is, what did I say, 17, and the new r or OP is 10, and you want to know what the x value is, it's a conversion. Divide with what you have times with what you want. Okay. So if you want to convert that 10 to the longer one, then you're going to divide with the same x or the longer x, because x divides with x, and you multiply with r or y, whichever one you want. Do you know the conversion? Divide with what you have times with what you want. Always. Okay, we will look at that one at a different stage. Remind me, because you look a bit confused. Right, I just want to finish the functions first and then we can go back to it. But it's the same concept. Can you see that? 5.2, the reference angles, and do you see the reference with the special angles? And do you see the two that aren't special, 27 and 63? But do you see they are complementary? So we're going to use a co-function. They cancel out. Same, over, over. Prove the identity. Fraction. What do we do when it's a fraction? Get the common denominator. What you do at the bottom, you do at the top. Simplify the top. Once you've simplified the top, either you factorize or you look for a identity in there. Never multiply the bottom in immediately, because then you've got two terms again. Keep it one term until you're stuck. You see, okay, I need to try something. Then you can multiply in. Okay. 5.4, general solution. Also one that I want you to look at. You can make a star here. You are keeping this, that you can maybe go and try it and see if you get it right before you ask the question. These memos are in any case online. It's available everywhere. It's available on that app, Mathematics Grade 11. You know that app that I showed you guys with that looks like an eyebrow on your phone? That one, it's on there. It's also at testpapers.co.za that I've sent you before. Everything is available, so you don't need to be stuck. That one is sin and tan. Now we are used to sin and cos. Nee? So, but tan is more sin over cos. Okay? And then on this side I've got sin. So if I were to divide with sin, this one would cancel out. Okay? If I were to divide with sin here, then I would times with 1 over sin. Then my sin would also cancel out. But now on this side I would have a 3. And here I would have 2 over cos. Because it's at the bottom. It can't just jump to the top. But if this is 3 over 1 and that is cos 2 over cos x, you know what to do. Just swap it. But do it on both sides. So you just put the cos at the top, the 2 at the bottom. You put the 1 at the top, the 3 at the bottom. Then you just swap both sides. A half is equal to 3 over 6. No? If I swap both of them, 2 over 1 is the same as 6 over 3. You must just swap both sides. Okay. problem solved. So what I say, it's the same thing, but they can put in a trick. But just try it. Don't just give up. Okay. Next page, you can look there. Then we've got the graph. As you see there, 11 marks. That's why I'm not going to keep going on with functions or with trig graphs that's not that big of a question. Okay. 11 marks there. We're going to quickly work out that question 6.1 to 6.6. And then question 7, you will see that is the sine and the cosine and the error rule. That's the part of the trigonometry that we haven't done yet. Okay. It's a bit of a different type of way. It's substitution, getting a specific part of the equation alone, solving the variable. Pretty easy. Okay. But now, to finish up with the graphs, I want you to do question 6 now. I'm also going to do it with you, but after everything that we speak about, I'm going to give you the opportunity, 10 seconds, 1 minute, to quickly write down the answer yourself. I need you to do it yourself. Okay. It is not working if you just sit there and listen to what I'm saying and copying from the board. It doesn't mean you know what you're doing. Okay. Now let's look at these two graphs. We read the information there at the top. The graphs of the functions f of x equal to a cos b theta and gx equal to c tan theta for x element of negative 180 to 180 are sketched below. The graphs intersect at P, which is 58 and 1,6 and Q. Please look at the marks allocated for each sum. 2, 1, 2, 2, 2. Do you see that? It's not big calculations. The only one that can be extremely big with the graphs is when it's that one that we just spoke about, where the two, you let the two be equal to each other, but then they don't have the same function. Okay. Those are the biggest ones. But you need to know your work. Okay. Do you know, when you look at the graphs, can you immediately notice which one is the tan graph and which one is the cos graph? Yes. Okay. Write down the range of f. F is the cos graph. Write down the range of f. I'm giving you 10 seconds to write down the range of f. The range is the possible y values. Are you done? Negative 3 to 3. Is there someone who doesn't know why it's negative 3 to 3? I need you to put up your hand so I can help you, please. Are you good? Yes. This next one is just a bit to think about. But it's easy, it's 1 mark. If m, there is m. No? Huh? There it is. If m is negative 45 degrees and negative 1, Determine the value of C. Now, do you know that when you've got a tan graph, you know where the critical points are? A standard tan graph. Where is it? What? 45 degrees. Well done, eh? So do you see negative 45 is a critical point, eh? Okay, so let's see if you can answer that question. One mark. In the equation. G of x equal to c tan theta. It's a small letter, mamparakies. Hi. Capital letter is on the graph. No? Small letter is in the equation. We remember that. You are now being like the grade 8s when they name the lines A, B, C, D, then they're trying to calculate angle A. But it's just a line where it starts and where it ends. You did that as well. Ah. Can I give you the answer? 1. Okay, let me tell you why. This standard mother graph of tan, standard, this one, there, has a critical point at 45 degrees and 1. Do you know that? The tan of 45 is 1. And I know they've given you the negative 45 here, but that's not really, it's a critical point, but it's not one that's going to help us. So you need to look at the first positive one here, because if the tan of 45 is 1, then we know that the amplitude is 1. If the tan of 45 is 2, then it means the amplitude of tan will be 2. Because you remember, well, when it's sin and cos, there's a calculation that we can use to find the amplitude. We say the max minus the minimum divided by 2, then we've got the value. Then we just need to check whether it's positive or negative. But with tan, we can't use that method because there's not a maximum and there's not a minimum. Okay, so you need to look at that specific critical point. But now, this one doesn't have a B value, so you must keep that in mind as well. Obviously, if there's a 2 in front of theta, then the critical point will no longer be at 45, it will be at 22 and a half. Then if it's at 22 and a half and 1, then I know the amplitude is 1. But if it's at 22 and a half and 2, then the amplitude is 2. If it's at 22 and a half, the amplitude is a half. Do you understand what I'm saying? So you need to find that first point. If that 45 was at negative 1, the amplitude would be negative 1. Do you understand how to do that? Okay, great. Write down the values of A and B. That's at the cos graph. It's in the equation, eh? Okay, let's quickly look at it. That A in the cos graph is also the amplitude. Do you see that? We also just calculated the amplitude of the tan graph. But because it's sin and cos, we have a calculation, we have a formula that we can use. So we look for the maximum value, which in this case is 3, and we look for a minimum value, which is -3, and we divide it by 2. So 3 minus -3 is 3 plus 3. 6 divided by 2 is 3. But then you must remember that you must just check whether this graph is positive or negative. So the standard cos graph, when x is 0, it's at the top. If at x, where x is 0, it's at the bottom, you know the graph is negative. Okay, but this one is at the top, so therefore I know it's positive 3. Were you able to do that? Okay. Did you struggle with B? Now, I'm just going to explain to you. You can just look at it and see the answer. What is the period of a standard cos graph? 360. That means it takes 360 degrees to make a complete wave. Now, how long does it take this one to make a complete wave? It starts here. Remember, a complete wave is, it's ending right before it's going to start again. So if I look at this graph, starting here at the bottom, it goes up, then it goes down, and right after this point, it would be back there. So this is a complete wave. Does that make sense to you? And that was 360 degrees. If you didn't have the full interval, maybe you just saw from -90 to 90, then you need to understand that seeing that curve is only half of the wave. Because this graph is not going to continue and jump up here again, and jump up here again. It's going to take the down again. Do you agree? So it must continue in the same way as it starts there if you say that this is a full wave. Now, if you only had that part, you would say it takes half, or it makes half a wave in 180 degrees, and therefore I know it would make a full wave in 360 degrees. Does that make sense to you? The calculation that we use, I just want to show you that we did write it down, was here. No, we didn't write it down. We just spoke about it. We said that B influenced the period. Ne? So that you take the standard period, divide by B to give you the graph's period. But now we're working it backwards. Now we have the graph's period. We should know the standard period, and we want to calculate B. So do you remember I taught you it in grade 8 as well? If that is your variable, how do you get it out? Swap it around. So you can maybe go to the summary where we wrote this down and add it there. If you want to calculate B, you're going to say standard period divided by period is equal to B. Okay. So therefore, if you use the formula, which you didn't have to do, because you could, it takes 360 and the standard period is 360, so you could have known that B is 1. But if you use the method, standard period divided by the period is equal to B, and then it's equal to 1. Do you all understand that? Okay. I want you to try 6.4 yourself. I have spoken to you about something like this before, but we haven't come across a question in a question paper. Remember that the trig graphs, it's all repeating in the same way. You can basically say it's a reflection to the top and to the bottom. and it repeats over and over and over and over again. Okay, see if you can find the coordinates of Q. I will give you a hint, there's no calculation. Or well, it's maybe a minor calculation if you really suck at subtracting. It counts 2 marks, so you can't be spending too much time on it. Are you done? Can I give you the answer? Not yet. 20 seconds. (122° and -1,6). Who got it? Okay. Let's just see how we got it. Well done. Good job, you guys. As I said, it's repeating, it's reflecting, everything is the same. So if that space from the x-axis to P is 1,6, then that space from the x-axis to Q will be -1,6. That's the easy one. Basic reflection. Getting to the 122 might be a little bit more of a challenge, but I need you to look at the shape and the position of the graph. So from that 0 to P, it's 58 degrees. Now look at what the graphs look like there. It looks the same here, but just reflected to the bottom and flipped, or reflected again. No, reflected horizontally and vertically. So therefore I take 180 minus 58. And that is how I get 122. So it's not like 58 and then another 58 and then another 58. You can't assume that. Look at what the graph looks like at that place. and then look for a value that you know. Do you understand, all of you? The next one, 6.5. K lies on F such that Km is parallel to the y-axis. Calculate the length of Km. Now, if this was algebra, this was that long sum where you take the equation of the one minus the equation of the other one. Do you remember that? Big sum. Okay. It is, you can do the same thing here. But what is nice is that you have the x value. It's negative 45. And they actually already gave you that y value. No? So all you need is the y value on the cost graph. You see? Do they say anything about not using a calculator? Now I just want you to take a close look there. Although it looks like k is at 2, it's not at 2. Do you see that? That's how I know I'm gonna have to use a calculator. There's no way that you can know that specific value right there. Unless they, like with P and Q, they gave you a similar value somewhere. Maybe they gave you a value there, then you would be able to know it, but there's no way. So all you're going to do is you take your calculator and calculate it. And then give me the length of Km. Go, 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 go. I want us to finish this one quickly. So all you're going to have to do is you say 3 cos negative 45. Just substitute in negative 45. I got 2,1213. And when I look at k, I'm pretty sure I'm right. So therefore, the length of Km is 3,12. Do you see how you're overthinking things? Completely. I just want to quickly talk to you about 6.6. Read the question, they are being very tricky here. You know when a graph shifts 30 degrees to the right, we say minus 30. When the graph shifts 30 degrees to the left, we say plus 30. You know that. Listen to what they do here. If the system of axes, so therefore the x and the y axis, if the system of axis is shifted 45 degrees to the left and the graphs remain fixed, write the equation that's now represented by graph f. So if the axis moved 45 degrees to the left, what happened to the graphs? It moved 45 degrees to the right. Do you understand that? They didn't lift the graph and move it 45 degrees to the left. They lifted the axis and moved it 45 degrees to the left. So that means your graph has shifted 45 degrees to the right. And that's all that they do. That's all that they do. You need to read and understand. So therefore the graph has moved 45 to the right. And my equation will be minus 45. X minus 45. Okay, there with the other class, I just once again When to look at that one again? Sin x minus 30 equal to cos 2x. I take a step back, so I want to change cos to sin. But there's no 90 that I can throw away, so I have to put the 90 in. You get that? All of you? Then the functions are the same, you can throw them away. You just go on with the values. But before you divide with 3, before you get your x completely alone, in your final step, you add plus k times 360. Because remember, these graphs will keep cutting each other. They, like of this one, they don't just cut once. They don't just cut once. They keep on cutting. So therefore, you divide with 3 to become x, you divide by 3 to become 40, and you divide with 3 to become 120. That's one term. And then k element of z. Okay, I'm done with functions, alright. Tomorrow we start sine and cosine rule. I will upload today's class now.